Hello, I'm Waffles Are Better. In this video, I'll be showing you how to use decorators for your custom features in Minecraft Java Edition versions 1.16 and above. As usual, if anything about this changes in the future, there will be a pinned comment in the comments, either telling you how to fix it or redirecting you to a new video. Using decorators in your features, you should be able to create a custom biome like this with a bunch of custom features. This is a biome called the Insanity Fungal Forest that I recently made for Crazy Dude 1016 in my Discord server. And as you can see behind me, you can use custom features to create really cool stuff, like again, custom giant mushrooms with custom placement, and also those patches of black concrete and warped nylium that also use decorators to choose how they generate. So right here I have an example of the netherrack replace blobs feature type, and this I just copied from the original Blackstone blobs feature that you can find in slicedlime's vanilla worldgen pack. And so this is pretty small and simple. However, if I go into the actual file that I copied it from, you can see there's all of this stuff. The highlighted part is what's actually in the file. So as you can see, target name is netherrack, that's there. State name is Blackstone right there. And then this is the radius. But there's also all of these other things in the file, and these are called decorators. Basically, it will determine how the feature is actually placed. So let me get started by just showing you how to add decorators. What you're going to want to do is you're going to want to open a new curly bracket here. So let me just open all that and then bring everything out. I think just one line, and then this is going to need this at the bottom. So up here, you're going to want to put type, and then this is going to be Minecraft decorated. And then you're going to want to put config here, and that's going to be like that, and like that. Then I think feature here, I'm going to bring all of this out another one, and bring all of this in another one. I think that's good. Oh, and then I accidentally forgot this last curly bracket. So this right here is going to be your feature, which is the feature I already had, but now it's inside of this other feature called Minecraft Decorated. So after this entire feature, so make sure that you have these two curly brackets right here, because that's this curly bracket and this curly bracket closing. You're going to need to add another comma. And here you're going to want to put decorator, and then in here is going to be basically another feature type, but instead of a feature, it's going to be a decorator, which are basically the same thing, except decorators are not their own feature. So for example, I could just put this in a file, and I don't know, it'd do something. Probably wouldn't work super well. But once you add decorators to them, they're like separate features inside of features that determine how the feature generates. So again, just like a feature, you're going to want to put type, type, and the first one I'm going to talk about is the Minecraft carving underscore mask. There we go. And then, just like in regular features, you're going to want to put config, and then curly brackets. This carving mask decorator type is going to, by my understanding, only generate the netherrack replace blobs feature inside of an area that has been carved out by a cave carver. So you're going to want to put step, and this is just going to determine which kind of cave it will generate it in. So if you put air, it'll generate it in a normal cave, and if you put liquid, it'll generate it in the ocean caves that are filled with water. So this is probably not the best choice for my feature, but one feature that I did find that uses this is the seagrass feature that generates seagrass on the bottom of ocean ravines. That's the only one I could find, but there's probably one or two more. So this can be useful if you want to do that kind of thing. So the next one is also related to caves. This is going to be pretty similar, and you could probably use this instead of carving mask, but this is going to be Minecraft cave underscore surface. And basically what this does, it will place your feature on the surface of a cave. So to determine whether you put it on the roof of the cave or the floor of the cave, you need to put surface, and then this is going to be ceiling or floor. So for example, if you put ceiling, it will generate the feature on the ceiling, so like cave vines and the rooted dirt. And if you put it on the floor, then of course it'll generate on the floor of the cave. So this is going to be floor to ceiling search range, which I think determines whether it's a cave or not. So this is 12 for the cave vines, and so what I think this is doing is telling it that if there is a area where there is a floor and then 12 or less blocks above it there's a ceiling, that's a cave, but I might be wrong on that. So the next one is super simple. This is going to be Minecraft chance, and basically all you need to do here is put chance in the config, and this is just going to be a number that determines how likely your feature is to generate. So this will be 1 over whatever you put for chance. So if you put 10, it'll have a 1 out of 10 chance of generating, and if you put like 20, it'll be a 1 out of 20 chance of generating, which doesn't really make sense to me. I would think that chance would make it more likely to generate, but I guess that's how it works. So if you do 1 out of 10 again, that'd just be a 1 out of 10 chance of generating. The next one there is the count one, and this one is actually really useful. I've used it for a lot of things, but all you need to do here is put an int provider. If you don't know how to do that, I will probably have an iCard up in the top corner to the previous video where I went over int providers, and it'll also be in the description if I forget to put an iCard. So this is going to need to be type, of course, because it's an int provider, and I'm just going to use uniform, and then value. So min inclusive is going to be, I don't know, 50. And max inclusive is going to be, I don't know, 70. So that does need to be between 0 and 256, so you can't go out of that range. But other than that, this can be really any number you want. And so the way I have it set up like this is definitely way too much. You're not going to need between 50 and 70 of these. It's probably going to be between, like, I don't know, 3 and 5. But that means that between 3 to 5 of these features will generate close to each other. So the next decorator type is count underscore extra. And to use this, you're going to want to just delete the int provider and change count to a number. And then you're going to want to go down another line, and this is going to be extra underscore count. And maybe that'll be 3. And then extra underscore chance is going to be a number between 0 and 1. So this is probably going to be, I don't know, 0.5. So that'll mean usually there will be a count of 1, but it'll have a 50% chance to be a count of 4. There's also count underscore multi-layer, and this is just going to be the same as count, except for instead of generating them all at the same level, it'll generate them at different Y levels, so they can kind of generate on top of each other. So the next one is going to be count underscore noise, and basically what you're going to want to do is, again, just delete everything in the config. Then there's going to be noise underscore level. What the count noise does is it makes a random count depending on the random noise of the block that is generated. And so I don't know where the noise value comes from exactly, but I just know that it is random depending on blocks and coordinates. And so you're going to want to put noise underscore level. So the 3 parameters are noise level, and then below underscore noise, and then above underscore noise. Below noise and above noise are 2 different values. and one of them will be used if the noise is below the noise level, and the other will be used if the noise is above the noise level. So basically, depending on where the feature generates, it'll have a chance of choosing below noise or above noise. So the patch grass plane feature uses this. It has a noise level of negative 0.8. It's got a below noise of 5. I forgot that colon there. And it's got an above noise of 10. So this basically means that if the noise level at the block that it's trying to generate at is above negative 0.8, it'll generate a count of 10, and if it's below negative 0.8, it'll choose a count of 5. So the next option is count underscore noise underscore biased. And so what this is going to be is, instead of depending on only one noise value, it will gradually change with the noise. So an example of this is the bamboo in the bamboo forest. Basically what count noise bias does there is it should make the bamboo thicker and then gradually thin out at the edges, I believe. So if I just copy all of this and replace it here, there's the noise factor, which determines like how much the noise influences the generation. Noise offset, which is just offset from the factor, and I think provides some randomization. And then the noise to count ratio will determine the count to generate based off of the noise. So I guess if it chooses a noise of 2, it'll then be a count of 1, I think. That's just a guess. There's not really an explanation on how this works, but my assumption is the noise factor will be multiplied by the noise that it comes up with, and then it'll turn that into a count using the noise to count ratio. So another decorator, actually it has no config, end underscore gateway. And what this does is it will just add a random value between 3 and 9 to the height of your feature. So the end gateways and the end islands will be hovering a bit over the land. And basically this just increases the height of your feature to give it that kind of effect. So the next one is going to be Minecraft heightmap. Basically what heightmap does is it changes the Y value and makes it so the feature generates on top of the existing height map. So this is useful for features like trees to make sure that they're generating on land all the time, or basically any other features, like for example, if you want to make sure that something's generating on the bottom of the ocean. So the existing height maps are motion underscore blocking, and I believe this will place the feature on the highest block that is either solid or a fluid. So for example, basically any solid block or any liquid. And then motion blocking underscore no underscore leaves also includes anything in the leaves tag. And then there's ocean underscore floor, and this is going to not specifically be under the ocean. It's just going to be the highest block that is a solid block that is non-air. So this might end up being under the ocean, or it might be on land, depending on where it is. And then there's also going to be ocean underscore floor underscore WG, and this will generate it on the highest block that is not air and not a liquid and is solid. So this should just place the feature on the highest block that is neither water, lava, or air. Then there is world underscore surface, and this is going to find the highest block that is not air, so this could include water. And then there is world surface underscore WG, and this is basically just the same thing as world surface. So the next one is heightmap underscore spread underscore double, and this is basically the same thing as heightmap. It's got all the same parameters, except instead of generating directly on the heightmap, it's going to choose a random value between the bottom of the world and double the height map. I'm not exactly sure what this could be used for, but I'm sure it is used for something. So next is lava underscore lake, and this again will not necessarily generate a lava lake. What it will do is it will always generate this if it's below sea level, which is 63. And if it's above sea level, it will have a chance of 1 out of 10 to generate. And so that's why you can find lava lakes pretty common under Y63, but sometimes they will rarely generate on the surface. So you need to put count right here. And the Minecraft wiki says that this is unused but required, so I'm just going to say 10. So next is range. So what this is going to do is determine a range of height between which the feature can generate. So instead of count here, it's going to be height. And this is going to be an int provider. So type. Actually, instead of an int provider, it's actually going to be a height provider. So some of these are the same as int providers, such as constant, uniform, and bias to bottom, but there's also very bias to bottom and trapezoid. So if this is constant, then going to do value. So this is going to be either absolute, which will just be an absolute height, so it's always at a specific height. And this could just be, I don't know, y10, or it could be above underscore bottom, and this means that it's going to be about 10 blocks above the bottom of the world, or it's going to be below underscore top, and this means it'll be 10 blocks below the top of the world. So those three options are called vertical anchors. So I'm just going to use absolute as the vertical anchor because I think that's just the easiest. So this can also be uniform, and so then instead of value, this would be min underscore inclusive, and then you would also have the max underscore inclusive. And so, for example, if you wanted the height to be between 10 and 20, you could do this. This could also be biased to bottom or very biased to bottom, and basically those do what you would think. It makes it closer to the min inclusive value, and very biased to bottom makes it a lot closer to the min inclusive value. And if you're doing biased to bottom or very biased to bottom, you can also put inner and then a value here. And I don't know exactly what inner is supposed to be because there's not a very good explanation anywhere. But I think it's going to be probably the average value, but I don't really know about that. And then there is also trapezoid, which is basically going to be the same thing, except instead of inner, you're going to have plateau. And trapezoid is going to, I believe, generate like a trapezoid on its side, so it will be less common at the top and less common at the bottom, and the plateau value is going to be about where it is most common. But again, there is not much about this anywhere. After this, there are two decorator types with no config properties, so I can just go ahead and delete all that. Spread underscore 32 underscore above. This will just place it in a random location between y0 and 32. And then there is also square, which will add a random value between 0 and 16 to the feature's x and z positions. So this will just randomize basically the exact location of where the feature is. And the last one is going to be water underscore depth underscore threshold. And this again has a config property, so I'm going to add that back. And the only thing here is max underscore water underscore depth. And the Minecraft wiki says that this is supposed to be a height provider, but that's incorrect. It's actually supposed to just be a value, and it's going to determine how deep in the water this feature can generate. And this is used by swamp trees and probably a few other features. I know that it's used to say that swamp trees can generate 1 block underwater. So now that I am done with making this feature and adding the decorator, you can see that basically it'll generate a blackstone blob, and according to the decorator, it's allowed to be 1 block deep in water. But obviously, when blackstone blobs generate, they're in the nether, so there isn't any water, so they wouldn't use this decorator type. So here are all the decorator types that the blackstone blobs use. It's got the count to determine how many of them are going to generate. It's got square to randomize exactly where they generate. It's got range to decide the location up and down where it'll generate, and that is basically it. So the way that the default Minecraft files are actually laid out is a little bit confusing, so I'm going to change the layout a little bit to see if I can make it less confusing. So I've redone all of this in a more understandable way. So you've got this whole thing, which is a decorated type feature, as you can see at the top. The config says the decorator type is count, and there's a count of 25, and then the feature for the decorated feature is another decorated feature type, and the decorator for that is square. So what that means is there are two stacked decorators and then another feature. So it will have a count of 25, and it will change the X and Z of each one to randomize the exact location. And then the next feature is another decorated feature, and this determines the range. So this height actually doesn't really do anything at all. So this decorator inside of this decorated feature, all it's doing is saying that it will generate between 0 blocks below the top of the world and 0 blocks above the bottom of the world. And then it finally gets to the feature. And this feature is netherrack will place blobs, and it will target netherrack and place some of it with blackstone. Again, the feature type is decorated. It adds a decorator, and then creates another decorated feature inside of that, which adds a second decorator, and creates a third decorated feature that is already using both of these decorators, and that adds a third decorator, and then this third decorator plus these two other decorators, count and square, are the ones that apply to this feature right here. And I feel like with this new format that I've just made, it's a lot easier to understand than this, because this just gets a bit complicated. Although for some people it might be easier to understand. It's basically all on the bottom of the document instead of all on the top of the document, because as you can see it says decorated and config decorator count, decorated and then config decorator count. It's all the same thing, it's just located somewhere else in the file. So here's a few more examples while I'm at it. There's the kelp. As you can see, it uses the count noise biased, which is basically going to make it to have a gradually higher count. It uses square to change the exact coordinate of where it will generate. It uses heightmap to make sure that it's generating on the ocean floor and not on top of the water. Then there is the lake lava feature. It uses chance to decide how likely it is to generate. It uses square. It uses range to choose the approximate y coordinate of where it's going to generate. It then uses the lava lake decorator type, which makes sure that it usually generates under sea level, but sometimes generates on the surface. And then here's the actual feature that determines that it is a type of lake, and it is filled with lava. That's it for this video. If you have any questions about anything I covered in this video, or any suggestions for anything you want to see in future videos, then you can give me those in the comments, or you can join my Discord server in the description. Again, just like the last feature video, I'm sorry, but I'm not going to put a download for this, because I didn't really create a final feature. But using this, you should be able to create any type of feature you want, just like this behind me, or even more. What's interesting is this biome behind me actually has to use several features to actually get the mushrooms to generate at all by replacing mycelium blocks with endstone. And I can get into that in a future video or help you with it in my Discord. But as of recording, I'm almost up to 250 subscribers, and I really never thought I would get this far. Never thought I'd get more than, I don't know, like 10 or something, and definitely not this fast. So thank you guys so much. I really appreciate you guys. Thank you guys so much for watching.